Welcome back to part 6 of e-swapping my Toyota pickup. Today we're talking motor controllers. It's about to get nerdy. This is one of the more important decisions you'll make, so it's best to do your homework. The motor controller controls the motor. Go figure. More specifically, it modulates the power being sent from the battery to the motor based on your input. Honestly, I tried making my own controller from scratch, but I just couldn't get it to work, probably because programming isn't my strong suit. Maybe someday I'll pick it back up. So I ended up buying one. And when you're looking for controllers, there are a few main things to consider. AC controllers and DC controllers are different, so make sure you get the right kind for whatever motor you're using. Make sure the current and voltage capacities are in line with your motor and battery setup. The current rating of your motor and battery can exceed that of your controller, but the reverse is not true. Also consider how it will receive throttle input from the driver. The most common I have seen is a 0 to 5 kilo ohm wiper potentiometer, which I'll cover how to set that up in a separate video. It's basically your gas pedal. Consider if your controller should have overvoltage and overcurrent protection, which is recommended, and if the parameters are configurable. I use a Curtis 1205M6B403 controller, and using this ancient programmer that I got, I can change different parameters such as throttle maps and deadbands. Plug breaking is a common feature where the motor is temporarily used as a generator, and energy from the moving vehicles is dissipated in the form of heat through a resistor within the controller. If you want to use plug breaking, make sure your controller is capable of that and pay close attention to the wiring diagram in whatever user manual you have. Most controllers have bus bars for high voltage connections. These bus bars are labeled with separate inputs for the positive and negative battery terminals, the negative motor terminal, and a plug breaking diode if applicable. Wire up high voltage connections from the battery and motor to the controller with insulated wire. I recommend at least 2-aught gauge. Most controllers will have a large capacitor bank inside which needs to be pre-charged, or they could be damaged by inrush current. In the next video, I'll go over how to set up a pre-charge circuit and how to tie the motor controller into an existing car's ignition circuit.